I'm super excited today because I love to talk about acoustics because, fun fact, to myself, if I wanted to go back to school, because people always ask me this, that's probably a thing I would go back and study and wished I had. There wasn't a lot of knowledge about it in the olden days when I was in school. But I find it really interesting, and we have two incredible badass women engineers with us today. So I want to welcome Annie Scalmanini, I hope I said that right, who is an acoustic engineer. They're both acoustic engineers at Apple, and Dee Fisher. Annie has a really, I'm sure she's going to get into this way more than I am, but I'm super interested in both of them because they have these kind of journeys from Annie, atmosphere, energy engineer. You're going to have to talk about that. Then to mechanical engineering, and then studying, of course, music production and audio production, and then that all somehow has come magically together into being this wonderful acoustic engineer at Apple. And Dee has a similar background from starting in mechanical engineering and then both via graduate school into acoustic engineering. So this is going to be super interesting to see how both of their journeys, what their journeys looked like, I guess, and then also how that manifests into like creating products basically for Apple. So I'm super interested. I'm very grateful for you both taking the time, energy today to talk with everyone. And I'm going to turn it over, I think, to Annie because you have the deck, but welcome to you both.
Thanks so much, Terry. I will pull it up right now and let me know if you guys can all see this. We good?
Yes.
Great. All right, here we go. So thanks for the intro. That was, yeah, you knew more about my background than maybe my husband does. But anyway, we're going to talk about exploring audio careers, acoustic engineering, and we'll dive right into it. We'll get a little bit into our stories in a couple slides, but first, what is it? And I kind of joke on the left there, obviously it's posing anechoic chambers. So, you know, most acoustic engineers have some sort of photo of them like this in a big chamber, but in reality, what we do really depends on the industry. So you'll find acoustic engineers in pro audio. You see huge, huge speaker arrays at outdoor venues. Consumer electronics, anything with a speaker or a microphone, which is basically all of our devices these days. And this is the field that Dee and I are in, so we're going to focus on that one today. You'll find us in architectural acoustics. Dee also pointed out that forensics, they hire acoustic engineers, climate science, and then finally, one of the fun things about this field is that more and more industries and companies are realizing they need this skill set. And so it's just expanding across industries. Automotive's another one. So it's a really fun field to be in. Has been niche, I think, for the last couple of decades, but is continuing to grow and expand. And it's also, an incredible way to marry interests. If you like, science, sound engineering, and then you also like music. That's one of the things that brought me to this field. So go on to the next one. So like I said, today we'll focus on consumer electronics, specifically acoustics engineering on consumer electronics products. What does that look like? It might be your studio monitors, the headphones I'm using right now, tablets, laptops. Admittedly, there's a gray area. There's some overlap between pro audio and consumer electronics, but I figure this crew can get down with non-binary categorization. So moving on, before we dive into some of the specifics of what we do, Dee and I'm going to try and get her video up so I can at least see her, but Dee and I are going to talk a little bit about our journeys, how we ended up in this field. So the long and winding road. I'll start with mine and then I'll pass it over to Dee to talk about her journey to this field. So childhood, I developed a huge love of and interest in music. I think my first memory is seeing my mom play a song really fast on the piano, and I just was hooked. I was like, I got to learn how to do that. And then, you know, divergent interests, like Terry said, I studied atmosphere energy engineering for a while, and then realized that I really liked being in the machine shop on campus. I loved making things, learning how things were made, and then designing and making them myself. So that led me to mechanical engineering. Just a bit of a plug for persistence. I applied to the program twice. I got rejected the first time, and you know, just kind of like, well, I really want to do this. So came back at it the next year, and eventually they said, okay, they'll let me in. And so studied mechanical engineering, and when I finished my studies there, and another quick plug for graduate studies, I was able to pay for them with teaching assistantship. So that's a great way to be able to kind of attain higher learning, is being a teaching assistant for other lower level courses, and then, you know, take your own studies at the same time. And that's often where I learned the most, was actually in teaching some of the lower level courses. And then finished the degree, and like, okay, I got to go get a job. Applied to a lot of things, got rejected from a lot of different things, wasn't sure what field I wanted to enter. Started out designing touch sensors, and learned a lot about consumer electronics there, how they're made, you know, the different types of fields and specialties within that, working on computers, tablets, phones, etc. And while there, got inspiration, or fuel, I should say, to start writing a musical. Again, kind of a, you know, this long and winding road, and realized that I needed to expand my toolkit to get the sort of sound I wanted for that music. And that's what led me to kind of discovering really this world. I mean, it was probably my mid 20s, discovering the world of sound engineering and music production. And so then I took a year off to study that, and, you know, learned a ton in Logic and Ableton and Pro Tools. Was in the studio a lot. It was a just incredible experience. And while in that program, started kind of reaching out to former colleagues and other people I knew, and that's what eventually led me to the field of acoustics, and specifically this role where I've gotten the massive pleasure and honor of working with Dee. So I'll kick it over to Dee to talk a little bit about her story.
Okay, can you all hear me? All right. So my music background starts with MTV. I was, you know, just like a toddler or a little kid when MTV became huge, and I just loved music and dancing. And then I learned to play an instrument at some point, and was part of a marching band. And marching band is kind of like choreographed dancing as well. And so I just knew that music kind of connected me with my brothers and sisters who also liked music and dancing. But then I was about to be an adult, and so I knew life was about to get real fast. So I didn't really know what to do. I didn't really have a lot of advice on how to go to college or how to pursue a career. I pretty much just got pushed by one of my teachers to go attend a college. So I enrolled in the University of Texas at Austin. And I wasn't originally enrolled in an engineering program, but I knew I was good at math and science. So eventually I pursued that, not really knowing what to do with it. The school has an acoustic engineering program, so I started taking coursework in that, because that was just kind of like a reach, like maybe this is some way to get back into music and dancing and something similar to what I love, but I don't really know how to get there. And that led me to doing research in underwater acoustics, which I was pretty much mapping ocean floors and studying the movement of fish and swimmers, which is, I wasn't really quite listening to music and dancing, and I knew that, and academia was just kind of like, it felt kind of like a dead end for me, like I wasn't really going to thrive and, you know, be my best self while studying underwater acoustics. So I quit that research position. I got a master's thesis out of it, but I didn't continue down the road of academia, and I was broke for about a year. But I was hitting the clubs. I was breaking. I tried to join a crew. I was a bedroom DJ and hanging out with some DJ friends. And so that made me happy, but I was so broke. And this was 2005. So there weren't many audio jobs back then. If you talk to a lot of acoustic engineers in the field today, a lot of them will say, like, can you believe how many acoustic jobs there are now? Because if you wanted to be an acoustic engineer 10 years ago, there just weren't any jobs. So I went to go do mechanical design of consumer electronics, but not quite acoustic engineering. And then I quit that job and went into architecture, architectural acoustics, but it wasn't quite, they don't, well, I shouldn't say this, but it wasn't quite a very deep practice of the science of acoustics. So I continued my job search to look for something better. And then eventually I ended up at Apple, where now I'm designing acoustic systems for consumer electronics, and it's where I'm happiest. And I feel like I'm back with my brothers and sisters again, people who enjoy music and dancing, people like Annie, people like the people at Wham. So that's my long and windy road.
Awesome. Thanks, Dee. And like I said, hopefully we'll kind of pass the ball back and forth as she wants to chime in. I have a ton of respect for Dee. She's been an incredible mentor for me as I have kind of come up to speed in this field. I just joined within the last year, this group. So here we go. So, okay, so acoustics engineering in consumer electronics, kind of now that we've talked about how we got here, what do we do? So different jobs of the acoustic means that over here on the left, we ensure that acoustical integrity is maintained. So the sound that we want the product to create and the sound that we want the user to experience, that's going to cross over many domains. It crosses over physical, so the actual pressure waves that create sound, the electrical, so as the signal travels through circuits, and then the software domain, for example, is that audio signal gets transmitted over the air between Bluetooth antennas, for example. So we're really looking at the system as a whole and making sure that as we integrate all these complex pieces, everything from the acoustical modules, the speaker and the mics themselves, to antennas, batteries, all the different things that go into a pair of consumer electronics, headphones, earbuds these days, making sure that, again, that sound quality is maintained. So what does this look like? We characterize the mechanical system as it impacts acoustic performance. So mechanical system is the physical thing. So the cushions and the headband, those can impact sound quality, how well it seals against your head, for example, or in the case of these earbuds, how well the tip seals your canal and cancels out ambient noise. There's another specialization in this field where people look exclusively at unwanted sounds, noises and vibrations, buzzes, squeaks, and rattles. It's kind of funny to say out loud, but it's true. That can adversely impact your experience of the product. There's a whole team that tunes the product. So make sure that as you listen to different types of content, podcast, music, etc., that again, we're getting the intended sound quality. And this is really similar to sound engineering. They deploy a lot of the same tools that you used in production, compression, EQ, etc. Not as many of the fun ones. We don't get to play with all the same plugins as you would in your production, but still a lot of great overlap there. And then finally, you have people who are very deep on designing the modules themselves, so the actual transducers. And transducer is just something that converts one type of energy to another type of energy, so electrical to acoustical and vice versa. So that's your speaker and your microphone. I like a really simple way of thinking of them is just inverses of each other. And so there are people who go very deep in design, electrodynamic driver for the headphone, and then what we call a MEMS microphone, micro electrical mechanical system. I think it's just very, very tiny microphones. These things are delightful. You look at them under very high magnification, and it's incredible that they can pick up my voice right now and convey it to you guys. Anything else you want to add here, Dee? Anything else you think we should talk about? Good. Okay. So let's look at this kind of a different way, just a slightly different layout of similar disciplines, but this is some of what our coworkers do. Like we said, they work on tuning the product, so they're going to look at EQ curves, and this is an area or a field where it's so important that, and this is, you know, for any acoustic engineer and obviously sound engineer, that you really work on your subjective listening and just ear training and really learning how to listen critically. That's super important for this discipline. I will just highlight the asterisk. Currently, this whole team is comprised of men. They are awesome and their ears are fantastic, but women listen to these products, and gender nonconforming people listen to these products. So we need some other ears up in here. There are people who, like I said, design the transducers, picture of an electrodynamic speaker. Those are also kind of delightful systems from a mechanical perspective. These are the very small microphones I was talking about. You have the tiny little membrane, and then usually just a hole for the pressure waves to get through. What Dee and I do, which is really focusing on integrating the pieces, and making sure that as you put everything together, everything from, you know, what we often call the enclosure or the housing, the in this case a much smaller driver, much smaller speaker, microphone, and then many acoustic meshes to protect the components behind them from external contamination, and then the compliant ear tip to make sure that, you know, across a wide spectrum of anatomy, these things will fit. There are people who simulate performance, so they get in tools. We'll talk a little bit later about tools that people use that we use to do our job, but they work on simulations so that before we've ever built a prototype, we can get an idea of how it will perform, and this just helps save us both time and money. And then finally, once you've actually built the thing, once you have the prototype, we have to validate the performance. We have to make sure it works as we expected it to. And so that's where a lot of the measurement and comfort with audio equipment comes into play, because you'll get in a controlled environment, you know, maybe like an anechoic chamber like we saw in that first picture, or another kind of isolated room, and take these measurements. Okay, let's see. How are we doing on time? Cool, I'll jump into, I think we just have a couple more. So a lot of text. I hate slides with a lot of text, but I like to call this the trifecta. You know, there are many different facets to our job, but in general, you can kind of bucket what you need in terms of knowledge. You go get these knowledge and skills. On the knowledge side, different fields that people have backgrounds in our group, physical acoustics. So again, that's just kind of the science or the physics behind sound in our case. And then there are people who are more in depth on signal processing, data science, because often we'll take measurements across a big cross-section of the population, for example, and you need to be able to look at those results and say something about them. And then the hardware design also, what we talked about with people designing the speakers and the microphones, etc. So that's kind of some of the knowledge buckets people have. On the skills front, so how do you then take this knowledge and translate it to a product? That's things like we first talked about. Subjective listening, ear training is a big one. I mean, I know everyone thinks, everyone in our group would probably characterize themselves as an audiophile, but you know, but truly, it's very helpful and important to really just, you know, trust your own ears and know how to listen critically. Software tools that people use, and again, I should take a step back and just say that no one person in our big organization of 400 plus years is a specialist in every single one of these. We have these skills peppered throughout the organization, and that's what makes it really effective and really fun to go to work, is to be able to learn about each of these different things from your coworkers. The different softwares or tools we'll use is MATLAB, which is every engineer has the love-hate relationship with, Python, which is free and open source, COMSOL for simulations, Max for audio prototyping, and then DAWs are kind of multi-track tools like Audacity or Reaper. I think Reaper is also free or open source. Other skills, audio prototyping. So, you know, hooking these things up, knowing what goes where, what to use, and kind of signal flow, interfacing mics and speakers with sound cards, driving multi-track playbacks or recording, and then acoustic measurement, again, kind of familiarity with some of this gear and calibration, etc. And then finally, resources. So how do you go about, again, kind of attaining some of these knowledge and skills? Obviously, formal coursework through a program. I put here Penn State because I feel like a non-trivial number of my coworkers did graduate studies at Penn State. I personally didn't, but I know a lot of people, they have a really good acoustics program. But there's a ton beyond just formal coursework, and most of it is free. I've done a number of courses on Coursera online. I don't know how to say this. Dee turned me on to Cadence, I guess. I had never heard of them, but they're a cool looking website. Khan Academy is great for fundamentals. Like before jumping into an acoustics course, Khan Academy is really good for like if you just need introduction to electrical engineering or just introductory physics. This is a really accessible website, really, really good coursework. Product teardowns, watch those on YouTube, just kind of learn the names of things and how they're put together. And then reading good old fashioned books, which were, you know, you can now use ebooks, so you don't have to break your back. This is kind of the main one in the field, acoustics, sound fields, and transducers. This is a great PDF I think you can find for free online. I'll send out some resources after to the WAM team, but loudspeaker design cookbook, and then AES papers are another great resource. So that's kind of the trifecta, and then we'll jump to the last slide so that we still save some time for question Q&A. Okay, so acoustics engineering, passion to passion, like dollar bills. You need to get paid for the work you do. So, you know, how do we translate all that we've talked about into jumping into this field if it sounds interesting to you? First question I think that everyone has to ask themselves is like, how do you figure out what jobs are out there? And then once you figure out what's out there, how do you then sort through that and figure out what you might be interested in? Some standard resources, LinkedIn, Glassdoor, company job websites themselves, word of mouth, your own knowledge of the industry. This is something where I think, like I really encourage you to, you know, ask yourself questions. I love the monitors we have in the studio. Who makes these? Ableton's the best DAW, and I'll fight anyone who says otherwise. Do they make hardware too? Fun fact, yes. I'm sure all of you know that. So, you know, again, kind of thinking about both the traditional routes and then non-traditional routes for thinking about what jobs are out there. Okay, so you found the job you're interested in. How do you convince them you're as awesome as you are? You can always apply online. But often that can be, depending on the size of the company or who's on the other end, it can be a black hole for your resume. So it really helps if someone can send your resume directly to a hiring manager or recruiter. So always check your network, you know, your current classmates, people you study with, instructors, friends you have both IRL and on LinkedIn, your social medias, cousins, ex-girlfriend, whoever's out there that that is even peripherally related to this field or a company that might be of interest. See if you know anyone who works at these companies or used to work there, and definitely leverage that, because that'll just help, and it'll help your own sanity from, you know, sending out a bunch of resumes and never hearing back. That can get discouraging, for sure. And then most important thing, you do not need to have all of the qualifications listed in a job description. Bears repeating, you do not need to have all of the qualifications listed in a job description. Those are often, you know, a laundry list that a hiring manager decided to put a bunch of things on there You do not need all of those qualifications. Apply to things, you know, even when you have 60% or something, you know, build up your skill set, but don't be dissuaded by over-spec job descriptions. So that's kind of the end of the formal presentation. I don't know, Christina, if you want to change our layout more to gallery view or how you want to do Q&A, but that's what we had for this morning.
Thank you. That was so fantastic. Like, just awesome. I loved your little life journey in picture format. Was just kind of pure genius. I loved it. Loved it. You guys are awesome.
Great.
The questions are flowing in, so I'm gonna start. I would say, let's start with this. What's the most challenging part of your job?
Most challenging part. I'm curious to hear what Dee says, and Dee, please chime in on these too. It's good for everyone to get two perspectives. I think for me, honestly, one of the most challenging things is just is the people. It's both the best and most challenging because you have to work with a really cross-functional group and many different fields, people doing, responsible for different aspects of the product. And so, you know, making sure that everyone's kind of on the same page, and that, especially these days of remote work, that you're not getting your wires crossed. And, you know, I think we're going down this path with this plan, and then someone else thinks it's the other. That's one of the most challenging things.
For me, communication is the most challenging part of the job. My communication, understanding other people's communication. The thing about the science of acoustics is that for most people, it sounds like voodoo magic. When you explain to them that there's, you know, room modes occurring in a space, they don't really understand what that is and why that's happening, because you can't see sound wave propagation. And now we have simulation technology to help us visualize that. But if you don't have a simulation that you can display to somebody, they think you might be duping them. Or so your communication, explaining how a loudspeaker works, explaining how sound waves work, explaining how audio signals work and how they, you know, can become corrupt through software and things like that, is just really difficult task. And for us to work together, we have to be able to teach each other about all these different parts of the audio system.
Super helpful. Another question, what does your toolkit look like? So are there any particular measuring devices or software that you consider really essential to your job?
Yeah, I think for me, one of the tools I've been using a lot lately is MATLAB, just because we work with a lot of different vendors, and you get data in a lot of different formats, and you get piles of it, and it just becomes mind-numbing if you're going to go through that all manually. So just figuring out quick ways, and you can do this in Python too, which is free, just quick ways to process a lot of data so that you're not spending your days clicking through spreadsheets. Yeah.
At the very beginning of my career, which I imagine most of the audience are about to step into a career, or looking to step into a career, Audacity was actually a very huge tool for me to take a recording and to process it, and to look at the waveform, to look at the spectrum content of it. And then after, you know, getting familiar with Audacity and tools like Audacity, just the speaker and the microphone, because understanding acoustic systems is a lot about just developing an intuition for it by, you know, using a sound source, propagating acoustic energy through some space, and recording it at different locations in that space and seeing what that looks like.
Mm-hmm.
Yeah, I'm going to double down on the MATLAB just because it comes up in so many other careers. So I just want to add that. Yeah. Folks might want to check out MATLAB. What steps did you take to make the transition into your current career, since you kind of both touched on it, but maybe from the career just prior to the one you're in now, maybe?
Yeah, I'd say, you know, for me, it was a little bit after 5 years working on touch sensors, kind of taking a step back and thinking, okay, I don't want to do this for the next 5 or the next 20. I enjoy engineering and enjoy working on physical things. I really like working, that's what drew me to mechanical engineering. So how do I marry that with my interest in music and my desire to, honestly, I opened Logic for the first time, I don't know, in 5 years ago or something, and was like, this is really fun. How do I, make this part of my job? And then, found a sound engineering and music production program. And then while there, started looking around at the kinds of jobs that I could transition into after, and then tried to kind of focus some of my depth so that I would be a little more qualified for that job. So we had, a couple courses on acoustics. I don't have a formal education background in it. So for me, it was really about like trying to dive into that, ask for more resources, do more reading. And then once I was at Apple, start, really leaning on incredible mentors, badass people like Dee to teach me things.
So the question was, how did we step into the job? Was that right?
What steps did you take to transition from your last position to this one?
So the funny thing about acoustic engineering is that everybody comes from some different place prior to coming into acoustic engineering. So some people only have a math background and no experience in audio or acoustics. So I don't want to say that that's necessarily a prerequisite. For me, I felt like I really needed to build up my resume and kind of like broaden my skill set, my toolbox. And so I went to architectural acoustics just purely for that reason. I needed a job that says sound acoustics rather than underwater acoustics. And it didn't really teach me a lot about acoustics, but at least it was on my resume. So I had like all these little parts of my resume that kind of made me look better on paper. But I feel like if you just have a strong drive to learn, you know how to find out ways to learn things, and you can convince, hiring managers of that. That's really what you need. But just like Annie really persuaded us that, she has a background in sound engineering, but she has a strong drive to learn, and we were really convinced that she could learn anything.
Perfect. I think that kind of, this one still works. Maybe what are some specific things that somebody that's just starting out and wants to get into this field, what could they, for instance, put on their resume that would make them stand out? I would say MATLAB.
I would, yeah. Don't say MATLAB.
I would say MATLAB, but then, additional things.
Honestly, I'll send to Christina and Elena, I'll send some of these links directly to the courses, but I took a couple great courses on Coursera for free. They make it a really small button, like the audit button, but it's there. And one was in signal processing for music applications, and another was, I think, just kind of an intro to acoustics course. And so those were, and put that on your resume. Again, like Dee said, they really kind of took a gamble on me because I didn't have the formal background that most people in the group do. So, put that on there to show I'm capable of kind of self-led learning. And Coursera classes are a really good place to start. And if you don't have an engineering degree as kind of that I think was a help for me, is like having that foundation in engineering. If you don't have that, do some of these Khan Academy courses to build those fundamentals, just get your foundation in just basic physics and electrical engineering, for example, and that'll help. Those are, yeah.
Yeah, and you can do some easy projects like building. There's some like kid loudspeakers out there that you can put together with like paper and batteries and wires. And then also just like, creating a film and adding audio on top of it that you produced yourself. And you can do that with Audacity. If you were able to teach yourself that really goes a long way. It shows that you took the time to do it. And most people don't spend the time to put the detail into that type of work. So you've already like shown yourself more capable than a lot of applicants if you do those types of projects.
Yeah.
We have a question about noise control methods. Are you guys ready?
Noise control.
How have noise control methods changed as several aspects of human life, workplaces, movie theaters, etc., got louder?
Oh, super interesting. Yeah, I mean, I think one thing is you're seeing what we call ANC, active noise cancellation, kind of populate across more and more products. So that's one, whereas it used to be that products, it was just passive isolation. You know, it's just how well the cushions and the headphones isolated you from your, was that the question, Terry? How?
Yeah, I think that's perfect.
Yeah, and then also, oh, I had one more thing I was going to say. Go ahead, Dee.
Oh, it's just that question also seemed to refer to loudness. So I wasn't sure if it was a question about loudness or noise.
It's as things have gotten louder. So that was in there. Wait, let me go back.
Yeah, loudness about theaters, right?
Yeah, it was as several aspects of human life got louder, I guess workplaces and movie theaters in particular.
Also, we do the, Apple, I think now has one of the biggest hearing health studies ever conducted, or broadest, where I think they use your watch, maybe other third-party devices to measure the loudness of your environment in decibels. So that, and then they can give you little warnings of your integrated exposure over the course of the day, and if you're getting into territory where you could have permanent hearing damage. So that's a cool new frontier and area of focus.
Yeah, and it's a new space for discourse for acoustic engineers and audio engineers. For a long time, we didn't consider our hearing health as just a normal part of our health, just like wellness aspects, physical aspect, but your hearing is something that you need to manage and maintain all the time. So when you go to a concert, even if the sound engineer has decided that the concert should be very, very loud, you need to take the responsibility to protect the parts that are important to you. So for people who really appreciate audio and acoustics, our ears are so important to us. So take hearing protection with you, keep them in your purse and your backpack always, because you never know when you need to protect your important parts.
Yeah, totally.
And so that's a new thing that we talk about in our organization a lot.
If you could give yourself advice on your first day on the job, I'm not sure which job for you all this is referring to, so just pick one. What would that look like? No, what would that be? What would you say? If you could give yourself advice on your first day on the job, what would you say?
One is like chill out, imposter syndrome. Like, you're gonna be okay. Like, I think everyone is dealing with some degree of that imposter syndrome of feeling. I mean, massive on my first day working on touch sensors and first day in this org, massive feeling of I don't deserve to be here. And just I guess it's like you can't eliminate that. That's going to be there, but just be okay sitting with it and just kind of trying to put that in the background. And the second piece of advice on my very first day as like a professional, my very first job, dress more casual. I definitely dressed too formal and felt very awkward all day. At least in California, we're very, very casual.
So yeah, I have two pieces of advice for what I would have told myself on the first day. The first one is, if you don't know something and somebody makes fun of you for it, then there's something wrong with them. So I remember my first job, somebody was like, you don't know how to work a soldering iron? And I wish I told them, yeah, no, I've never soldered anything. I didn't grow up building cars with my dad, like,
right.
many guys do. So, but I can learn. It's just show me how to use it.
Yes.
And then the second thing is, if you're having a conversation with somebody, a technical conversation with somebody, and you don't understand what they're saying, it's not because you're dumb, or it's not because you're not capable of understanding. Technical communication is very difficult, and that person needs to maybe like give it a second go, try again. And you need to ask them, like, can you please explain that again? I didn't quite understand. And that's the job of everybody, is to transfer information to one another so that we can all work together. Mm-hmm. So never put it on yourself if you don't understand what other people are saying.
And you're doing them a favor by asking them to rethink how they're presenting, because they're going to have to communicate to all sorts of executives and depending on what company, maybe a client or something, who does not understand what they're talking about. So you're doing them a huge favor by saying, let's try this again.
And even if you're taking a class, I wish I had always put it on my professors, you know, like if they're teaching, if they're lecturing, teaching something, I wish I raised my hand and been like, can you explain that again? Like, I don't, and why do we need to learn this equation? This is complicated. Do we really need to know this? If so, please explain it again. I didn't catch it. So yeah, if you really want to do audio and acoustics and you want to learn it, then do your best to learn it. But then other people have to do their part too and like teach it well.
Mm-hmm. I love the technical communication comment. As an educator professor for so many years, that's like when you evaluate people, that's like the first thing. You're like, if you're overly if you can't explain it to like your 2-year-old niece, you're not doing it right. Like that's your job. So I love that. And I think that's for everybody. Like doesn't make you look smarter to like overly complicate your explanation. So like just let's get rid of that. Simplify. So I so appreciate that. I'm going to riff a little bit and ask you what, and I don't even want to say skill sets, but maybe like what attributes, and you know, I just want you guys to own this. Like what attributes do you feel like you each have that contributes to your success, that makes you successful? You know, it might be like focus or whatever it is, but what do you think's really driving your success?
Well, I think first just acknowledging my privilege, and just like I grew up with a family where education was important, and you know, and my mom and dad would sit with me through algebra homework and be like, you know, be okay with me getting frustrated and stuff. So having that was a huge, you know, just like a huge leg up to start with. And then I think in the workplace, I've noticed that my ability to form relationships has really helped me learn and grow, and you know, get chances to work on things. And when your coworkers like working with you, they're going to want to continue doing it. Never underestimate how powerful it is to just be like a collaborative person, because the workplace has a surprising lack of them sometimes. So if you're collaborative and you know, like Dee said, very eager to learn and patient as a learner. If you don't just get frustrated and be like, okay, I don't get it, so I'm never going to get it, then I think that's really helped me, especially now being in a field where I don't have the, you know, the formal education that a lot of my colleagues do. Dee, what about you?
Well, first is my willingness to dig in deep into the details of anything. If I want to learn something, I will try to learn it to the degree where I can teach it back to somebody. And, you know, like Terry says, like if you can't teach it back to a 2-year-old, well, maybe not a 2-year-old, but if you can't teach it back to somebody who's not familiar with the topic, then maybe you haven't learned it well enough. And then the other thing is no work is beneath me. So I had a master's in acoustic engineering. I had 5 years experience in consumer electronic design. But my first job at Apple was a technician. They needed a technician, and I said, I'll do it. There's plenty to learn from being a technician and prototyping speakers and microphone systems. And I know how to do MATLAB, and I know how to do speaker simulations as well. So I'm sure you're going to ask me to do those things as well, even though those are not technician jobs. I will do all of it.
That's awesome. And perfect, because it's always something that I don't think that you're going to answer, or somebody else doesn't think you're going to answer. That's great. I think we have a gear question. What piece of gear has recently inspired you? And I'll just start there. There's a follow-up, but let's start with that one.
let me think. I think for me, one thing that was fun that I discovered on the job is this, I don't think it was in the presentation, but we call them hats, not this, but it stands for head and torso simulator. And my first day on the job, I walked into the lab, and there was like a plastic half man with kind of ear couplers and then microphones in the ears, and that's how we take a lot of our measurements. And Dee trained me on it, and that was just I don't know, kind of a revelatory, a little bit of a surprise and delight moment of like all of these plastic men sitting all around the labs where we measure our equipment. So that's, yeah, it's not a piece of home audio gear by any stretch of the imagination. Those things are grossly overpriced and meant for industrial applications, but those are pretty cool. Check them out.
Yeah, I don't know if this is going to be useful, but I really like USB sound cards. They're really expensive. I use RME, which is a German company, and it's just a real handy piece of equipment for an acoustic engineer. You can plug in multiple microphones and multiple, speakers, and it's USB interface.
Yeah.
I don't know. Yeah. I don't know if that's great advice. But...